Okay, welcome to paper 3 of the Year 11 PPE. This is the final paper, another calculator one, and just to remind you that you must show all your working to get the marks, and even if you do use your calculator for any question, still write down what it is that you're actually doing with that calculator. Okay, first question. This is expand and simplify. So show the steps. You're multiplying out the brackets, so you're doing first outer inner last. Okay, first term is x squared. Okay, the outer term will be plus 7x. The inner term will be minus 2x. Okay, and the final term would be minus 2 times 7, which is minus 14. Okay, that's the last term there. And then combine those two middle terms to give you x squared plus 5x minus 14. Okay, 2 marks for that. And the next one is about factorising. And what you've got to do is factorise it fully, which means that you've got to take out every factor that's in there. So you have a 5 and an x in both terms. So 5x comes outside the bracket, and what's left over is 3x. Okay, because 5x times 3x is 15x squared, plus it'll just be 2. Okay, and you can easily check by multiplying out to see that you get back to this. Okay, number 2 is about using a calculator. Well, you've just got to be careful to enter that exactly as it is there on the calculator. You don't need to write it down again, it's printed for you, but you do need to write down all the figures on the calculator display, which should be 168.62803. And they'll be looking for either 8 digits or 10 digits, but a minimum of 8 is normally what most calculators will do. And then you need to give the same number you've just written down to 3 significant figures, which of course is 169. Okay, and that's easy marks for those 2 questions. Now on this question, it says use the scatter graph to estimate Janice's mark in the French test. You're told that she got 45 in the English test. Well, don't just guess where to go with this. What you need to do is draw a line of best fit. So a line of best fit is a straight line that goes roughly through the middle of all the crosses. Okay, it's not an exact line, but roughly through the middle with about the same number of crosses either side. That's good enough. Okay, now she got 45 in the English test. Show how you get your answer. 45 in the English test. So according to my estimation then, she's got about 48 in the French test. Okay, so I just need to put 48, and it's supported by my diagram and my graph. Okay, don't try and answer that without drawing that information on the graph. Number 4, this is about mean from a grouped frequency table. And we got to work out an estimate for the mean time. And it can only be an estimate because we don't actually know how many seconds these 5 people took, for example. But what we do is we say on average they took halfway between 5 and 10, which is 7.5. Okay, and then we add to that 7 times halfway between 10 and 15, which is 12.5. Okay, then we add to that halfway between 15 and 20, so it's 8 times 17.5. Okay, and finally 22.5, 10 times 22.5. Okay, now you don't actually need brackets around any of that because the calculator will prioritize the multiplication. But just to help you see clearly those 4 calculations within that, I'm putting those in there, and you can do that as well if you wish. Put that on the calculator, and that will give you the total, which is 490. Okay, so that's the total time taken by all of those people added together to complete that race. Okay, so the mean time is 490 divided by the number of people, which is 30. Okay, and that comes to 16.3 to 3 significant figures. Okay, 16.3 seconds to 3 significant figures. Okay, so next question. Write this in millimeters cubed. Well, if you think of a centimeter cube as being 10 millimeters long by 10 millimeters high, okay, by 10 millimeters back, okay, so you've got 10 by 10 by 10, that's just the front part of a cube looking sideways on. Okay, then you can see that that's 1,000. So basically you just need to take this number here and times it by 1,000. So it's 53,000 millimeters cubed. Okay, Nelson driving the car to a wedding reception. 15:38 is the time that he left. He arrived at 17:23. So how long was that? Well, you see, if you went from 3:38 to 4:38, that's 1 hour. Then you go to 5:08 is 1.5 hours, and it's fairly quick to work out that it's 1 hour 45 minutes. Okay, but 1 hour 45 minutes is equal to 1.75 hours. In other words, 1 3/4. Okay, and you've got to find his average speed, which is distance divided by time. So you simply want 91 divided by 1.75. Okay, and on the calculator that comes to exactly 52 miles per hour. Okay, next question, number 7. Write that in standard form. Okay, remember the number you start with must be a number between 1 and 9.9 recurring. So 5.248, okay, is what you start with, and that's multiplied by 10 to the power of, and I'm starting from here, 1, 2, 3, 4, 5, 6, 7. 10 to the power 7. Now, write that number as an ordinary number. So I've got to start with 787 and count backwards 5 places. So I'm going to end up with a 0. Then I'm going to have another 4 zeros, then the 7, and then the 8, 7. You can check that back because from here that point goes 1, 2, 3, 4, 5 to put it into standard form. So that's the answer to that one. Okay, and the next question here is a comparison between two numbers. And Alice is saying that because 7.21 is bigger than 5.73, this number A is bigger than B. Well, of course, that's not the case because B has an extra power of 10. So you just need to say that Alice is wrong or no, incorrect. And then you need to just say why, because since 10 to the 8 is greater than 10 to the 7 by 10 times. That's what I'm going to say. Okay, some reference to the powers of 10. Okay, angle reasoning. Now, it says here you've got to show all your working, but you don't have to actually write down any reasons. So it's just asking for working out to be shown. And some of that can be on the diagram. Okay, so you don't need to write the reasons down. So that one is 123. I can just add that on because it's opposite angles in a parallelogram. And this is 57, and a little bit of working to show 180 minus 123 equals 57. Okay, so that's 57. So the examiner can see where you got the 57 from. Okay, so that's one piece of information I need to work out x. And now I'm going to use something about the exterior and interior angles of a pentagon. So if I take an angle on a regular pentagon, extend one of the sides like that, then I'm going to create an angle of 72 degrees. That's called the exterior angle. Okay, because that comes from 180 minus, well, it comes from 360 divided by the number of sides, which gives me 72. Okay, so that's where I get the 72 from. And then if I take the 72 from 180, it gives me the angle inside the pentagon. So I subtract the 72, and that will give me the 108. Okay, so this is 108 because it's on a straight line. That's the interior angle, and so is this one here. That's all 108 as well. So x is going to be 108 minus 57. Okay, which comes to 51 degrees. And that's the answer to the problem, and there's sufficient working there to show where all that came from. Next question. This is about an enlargement. Now you've got the centre of enlargement and the scale factor. Okay, so all you need to do is say, well, if that's 1 unit away, it's going to be 3.5 units away on the enlargement. So from that centre of enlargement, I got to go to 3.5. Okay, and the height of this is 2 units from 1 to 3, so the height of the new one must be 2 times 3.5, which is 7. So it's going from 1 up to 8. Okay, so that it has the appropriate height of 7 units high. And then it's going across 1 there, so it needs to go 3.5. 1, 2, 3, 0.5. Sorry, 1, 2, 3.5 there. Okay, so that's the three. They're the 3 vertices, and I just need to join them together. Okay. Now you can put in what we call ray lines to show how the enlargement was done. That's more useful if you've got plain paper or not a very good grid, but because this is quite a detailed grid, it's quite sufficient to do it without. But just to show you what the ray lines would look like, I'll just do them in a green colour. You would have one from here going through those points there like that, and then one from here would touch that corner, and then it should touch the corresponding corner up there like that, you see. Okay, that's how they work. And then there will be another one here through here as well. Okay, I'm just going to take that off because it if it's too solid, it takes the covers up the image of what you've just done. Okay, next question. This is about solving an equation. So all we need to do here is just the same thing to both sides. So 22 plus x, I'm timesing both sides by 9. 9 times 13 is 117. take away 9x, okay, because you're timesing everything on the right by 9. Add 9x to both sides. I've got 22 plus 10x equals 117. Okay, subtract 22 and I've got 10x equals 95, and therefore x is 9.5. Okay, I could have done those two steps in one, but you need to put some working in. Don't just go straight to the answer. Okay, next one, simplify. Well, hopefully you know that if you've got something squared and something cubed underneath it, you can cancel out an x minus 2 squared, okay, and that would give you, that would go, and this would just leave you with x minus 2 to the power 1, okay, so you're left with a 5 over x minus 2, because x minus 2 to the power 1 is just x minus 2. Okay, so it's a fairly easy simplification there. Okay, next question. Now, this is a probability tree with decimals on it, so it lends itself to the calculator. And basically calculate the probability that Amar will not be late on exactly one of the 2 days. So that means he can either be late on the first day and not late the second. So I'm going to use the notation, so not late is as n, right? So late is L, not late is N for not. Okay, so what I'm going to say is the probability that he's late on the first day and not the second, right, plus the probability that he's not late on the first day but late on the second. So either of those two situations are allowed. Okay, and so that's equal to 0.07 times not late, which is 0.98. Okay, so that refers to this first part, plus, and now I've got to do not late, which is 0.93 times late, which is 0.11 from the bottom part of the tree. Okay, so I've gone down this route here. And then I just got to put that on the calculator. Again, you can use brackets there if you want to, but you don't actually need them because the multiplication will prioritize. If you put that in the calculator, you will get 0.1709, which is the answer. Okay, and that's it. Next. Okay, we've got 27 snakes and we've got to make a box plot. So we need to know the median. If you've got 27 snakes, okay, the median length is the length of the 14th one, because you've got 13 snakes to the left of it and 13 to the right. So the 14th one is the median. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 14th one is 196. Okay, so I'm just going to put a little mark for the moment at 196. I'm just going to put it there. Okay, that's the median. Then I've got 13 to the left, and I want the middle of that, which is the 7th one. 1, 2, 3, 4, 5, 6, 7. So it's that 7 there. Okay. And afterwards, I want the 3/4 of the way along. So I need to go back 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7. Okay. And I've then got 6 to the right. That's right. And 6 to the left. And that one there. Okay, so the lower quartile is 187, okay, which is there, and the upper quartile is 207, which is there. Okay, you can be fairly precise on here. And the range goes from 171, that's the lowest length snake, and up to 217, which is there. Okay, so we've now got the 5 key pieces of information. So we just take some straight lines and we make a box. It doesn't matter how wide the box is. I'm going to make it 3 little squares like that. So I'm putting all the verticals in first, okay, on those key positions. And we often have a little dash at the end of each line, and they're already drawn. And then we just put the box around that, like that, and like that. And the whiskers go from there to there, and from there to there. Okay. Next. Okay, this question concerns finding the mass of a liquid in a cylindrical container. And the liquid's made of 2 different liquids mixed together, each with a different density. And we're going to work this out in several stages. So the first thing I'm going to do is find the volume of this container C. Okay, so the volume of container C is equal to pi r squared times the height. Now r is 4 and the height is 28, so it's pi times 4 squared times 28, and that comes to 448 pi. So that's the volume of the container that we've got to fill. We don't need to decimalize it, we can keep it like that. And we're interested in 2 fractions. Liquid A represents 3/14 of the total container. Okay, the 14 comes from 11 plus 3, and the container also contains liquid B, and it contains 11/14 of it being liquid B. All right, so just keep a note of those. Now the total mass comes from the density times the volume. So we'll take the mass of A first, which is going to be, or the volume, which is 3/14, okay, 3/14 of 448 pi, okay, times the density, which is 1.31. So that will give me the mass of liquid A in that container. And then I need 11/14 of the same volume, 448 pi, but that's made of liquid B, which has a density of 1.12. Okay, and you can put times signs instead of brackets in there if you prefer, but show what you're going to put into the calculator. Write it down clearly first, then put it in the calculator. It comes to 1634 to 4 significant figures. Okay, which is what they required in the question. But very important that you show how you work that out. It says that here, you must show what you're working. Okay. Next question. Okay, this question is about people going to a cinema, and we've got lots of ratios to work with, determining how many of them bought popcorn, how many bought sweets, Coke, lemonade, and so on. So what we're going to do is work with fractions here. So we're going to just notice that if the number of people who chose sweets to the number of people who chose popcorn is 3 to 4, then we can say that 3/7 chose sweets and 4/7 chose popcorn. Okay, so those denominators become important. So that's 7. Just going to make a note of that. That's 8, and this denominator here is going to be 10. Okay, so they're denominators that we're going to use. Now what I'm going to do is this. I'm going to say, let's use some abbreviations here. So for sweets, I'm going to use S, for popcorn, P, for lemonade, L, for Coke, C. Okay, so that's unique. I'm not going to get confused with those abbreviations. Okay, so what we know is that if you started at the beginning of this, then the sweets represent 3/7 of the people. Okay, so I'm just going to put 3/7 there, and popcorn is 4/7. Okay, so what I'm now going to do is notice that those who choose sweets, okay, the ratio of Coke to lemonade is 5-3. Okay, so that means that 3/8 chose lemonade. Okay, so sweets and lemonade is equal to 3/7 times 3/8. Okay, and the other way that people can end up choosing lemonade is that they had popcorn first and then chose lemonade. Okay, so popcorn first was 4/7, and of those who chose popcorn, the ratio of Coke to lemonade was 3-7. So it's therefore 7/10 of those who chose lemonade. Okay, and because there are 2 possible ways you can get lemonade, you add the probabilities together. Okay, so it's all the people who chose sweets and lemonade plus all the people who chose popcorn and lemonade. So anyone who chose sweets or popcorn with Coke are not included. So all I need to do is add those together. So the fraction that I need is basically these 2 added together. So it's that comes to 9/56. Okay, and this one here comes to 28/70. Okay, there's no need to cancel them down. Put them in the calculator. So I want 9/56 plus 28/70, and the calculator will give that to you in simplest form as 157 over 280, and that's the answer. Okay, next question. Okay, in this question we have to prove algebraically that the sum of the squares of 2 consecutive integers is always an odd number. Okay, now this is not too difficult. The thing not to do here is to just give examples with different numbers. That will never get you any marks because it says prove algebraically. So 2 consecutive numbers, if we call one of them n, then the next one is going to be n plus 1, the one afterwards. Okay, so there's our 2 numbers, and what we've got to do is sum together the squares of those 2 numbers. So what we're interested in is n squared plus n plus 1 squared. Okay, now if you multiply out that bracket, that gives you n squared, okay, plus n minus n plus 1 times itself. Okay, so I'll write it in full, then we do a FOIL on that, first outer inner last. Okay, and that will give us n squared plus n squared plus 2n plus 1. Okay, so when we combine all that together, we get 2n squared plus 2n plus 1. Okay, now you might be thinking, well, I can see it's going to be odd, but you still have to prove it. And this is what we do next. We notice that in the first two terms, there's a common factor of 2. So if we take out that factor of 2, we're proving that the first two terms added together is an even number because it has a common factor of 2. And if we have an even number plus 1, we're turning it into an odd number. Okay, so that's basically how we do it. And we just need to state under here that even plus odd, or even plus 1, means much the same thing in this case. Even plus odd is always going to be an odd number. That's a fact you can just state. Okay, you add an odd number to an even number, you get an odd number. Or you could say even number plus 1 is odd as well. Okay. Y is inversely proportional to the square of x. So I start by writing a statement of proportionality. Y is proportional to 1 over x squared. That's the first thing. Okay, next I write down that y therefore equals some constant k times 1 over x squared, or k over x squared, like that. Same thing. All right, then I use what we call the boundary information to work out what k is. So I'm told that y is 8 when x is 1.5. So I plug those into this equation. So I say that when y equals 8, so y equals 8, x equals 1.5 implies that 8 equals k over 1.5 squared. Okay, replacing the x and y with those values. Now, 1.5 squared is 2.25, which leads to k being 8 times 2.25, which is in fact 18. Okay, yes, 8 plus 8 is 16 plus a quarter of 8, 18. So k is 18. So I now write my equation of proportionality as y equals 18 over x squared, because I now know that k, the constant, is fixed at 18. And then it says find the negative value of x when y is a half. So what I now do is replace y with a half. Okay, so I have a half is equal to 18 over x squared. Multiply both sides by x squared. So a half x squared is equal to 18. Double both sides. X squared is therefore equal to 36. And x is therefore equal to either plus 6 or minus 6. Okay, because either of those, when you square them, you get 36. But it says find the negative value of x. So therefore, x equals negative 6, which is the value that they asked for. Okay, in this question, this is about graphical solutions of a quadratic curve and a straight line. Okay, so what's going to happen here is we've got the graph of y equals x squared minus 3. So it's like the graph of y equals x squared that's been translated 3 units down. Okay, and we've got to use the graph to find estimates for the solutions to this equation. Now this equation doesn't look like this one, but what we're going to do is we're going to split this up. Okay, so if x squared minus 2x minus 4 equals 0, then what I'm going to do with that is I'm going to say, okay, x squared minus 3 minus 2x minus 1 also equals 0. And why have I split it in that way? Because I started with what I see over here, x squared minus 3, which is the graph here. And what I'm now going to do is put the other stuff that isn't x squared minus 3 on the other side of the equation. So therefore, x squared minus 3, okay, must equal, add 2x and add the 1, you see, to the 0 that's there at the moment. So I've now got this. And so what I can do is I've got the line x squared minus 3 already drawn on the graph for me. If I now draw the line with equation 2x plus 1 on the same graph, then I can look at where the two intersect, and that's going to be the solutions to the equation. All right, so the line 2x plus 1 goes through the y-axis at 1 there, okay, and it has a gradient of 2. But be really careful here because the scales are different. All right, so you've just got to be careful. So it's not a line going up steeply like this, but for every one you go across, you go up 2. So in fact, it's going to be here. So it's going to go through the points. Well, we've got the point 0, 1, 1, 3, 2, 5, okay, and then we've got 3, 7, which is there, okay, and 4, 9, which is there, okay. So you have to be careful the gradient doesn't look like 2 because of the different scales. But that's the line we draw, and we draw it from there through those points, and hopefully it continues down there, as it does indeed. Okay, so what I've now created is 2 crossing points, which are the solutions, and I read off the values of x. And I'm estimating, I'll put these in a different color, so I'm estimating that reading that one off there is about 3.2, okay, and this one here is about, well, it's about negative 1.2, okay. So I'm going to say, because it says use the graph to find estimates for the solutions, so basically x is approximately equal to negative 1.2 and 3.2. Okay, next. Okay, in this question I see triangles without right angles. I see sides and reference to an angle. So this is likely to involve the sine and cosine rules. So something slightly unusual here, the size of DAC, that's this angle here, is 3/10 of this angle here. Okay, so it may not look like it, but that doesn't matter because these things are not drawn to scale. So we've got to calculate the length of DC. Okay, so we're looking for the length of this line here that I've highlighted there. Okay, so what I'm going to do first is use the cosine rule, okay, because I've got 3 sides that I know, and I know an angle between 2 of the sides, or I'm going to find out the angle between in there. Okay, so I'm going to call that angle here C, and I'm going to say that 4.4 squared, so that's A squared, you see, 4.4 squared equals 7.1 squared plus 7.2 squared minus 2 lots of 7.1 times 7.2 times the cosine of the angle between them. Okay, that's the cosine rule. The formula for that you shouldn't learn, but it's there. Okay, now if I rearrange that, I'll be able to work out what cos C is. So I can say that cos C, okay, is going to be, well, I need to take away, start with the 4.4 squared, and take away the 7.1 squared and the 7.2 squared, okay, which will just leave me with this part here. And then I need to divide the whole thing by the bit in front of the C, cos C, which is negative 2 times 7.1 times 7.2. Okay, so what I've done is I've just rearranged that formula there to give me cos C. And I can then find out what C is from the calculator by putting that in and doing the inverse cosine of that. Okay, and that comes out with the angle of C as being 36.40 degrees to 4 significant figures. So I'm going to work to an extra significant figure more than the answer. So that part there came out to be 0.8048. Okay. But I just kept that on the calculator and put shift cos answer to get this number here. Okay. Now, if it's 36.4, then this angle here at DAC, so angle DAC is going to equal 0.3 or 3/10 times 36.4. Okay, and on the calculator I don't actually need to work that out. What I can do is I can just go straight to using the sine rule now, because what I can do is use the sine rule here using this angle here, okay, which I can work out from what I've just done, and I can say that this length over the sine of this angle is the same as x over the sine of this angle. So if I just label those angles first of all, we know that the angle at C is 36.4. Okay, I can just fit that in there. Okay, that's using what we've just worked out. Okay, and I also know that this one here is 3/10 of that. So if I just label it as 0.3 times 36.4, okay, then I can work out that this angle here, which is angle ADC, okay, so angle ADC will be 180 minus this, okay. So if I just call well, if I can just use the sine rule as it is now, so I can say that x over the sine of 0.3, okay, so x over the sine of 0.3 times 3.36 rather, 0.4. Okay, it's the same as 7.2, okay, which is this side here over the sine of that angle there. And the sine of that angle there is going to be 180, or the sine rather, of 180 minus 36.4, which is the angle at C, minus 0.3 times 36.4. Okay, so you can put all that straight into the calculator like that, but obviously you just have to be very careful that you've got everything in the right place. And of course we need our fraction lines in there. Okay, and so from that we just have to multiply both sides by this thing here. Okay, so therefore x equals, okay, now a quick way of doing this is just to make a copy of this. Okay, save me writing it all out again. So if I just take that, make a copy of it there, bring it down here, so x equals that, and then just next to that 7.2 on the top I can just put the sine of this bit here basically. So I can take out this part, okay, and put that next to it there. Okay, and that completes the calculation that I need to do. So basically I brought that up there and put it next to the 7.2. Put that into the calculator and it will give me 1.855. Okay, that's using exact values from my calculations. Okay, and that equals 1.86, okay, to 3 significant figures. 1.86 to 3 SF, and it's centimeters. Okay, quite a tricky question, that one. Okay, and that's the answer there. Graph shows information about a cyclist's journey. Work out an estimate of the speed. So the speed on a distance time graph is the gradient at time 5 seconds. Well, look, there's 5 seconds. I'm just putting a little mark there. Okay, we want the gradient at that point. So we need to draw a straight line that's a tangent to the curve there. Okay, now this is quite difficult on the pen and tablet, but it's an estimate of a line that just touches here. Now here is that line, and you can see it's touching at this point here when the time is 5 seconds, and we just got to work out an approximate gradient of that line. So I'm just going to put some key values. I can see that that point there is 2.4, okay, and the end of this line here at the edge of the graph is at 9, okay, and then vertically it's reaching this point here, which if you read off over here is 18. Okay, so basically I've got a right angled triangle with a height of 18 and a distance along the bottom running from 2.4 to 9. So the gradient of that is 18 divided by the difference between 9 and 2.4, okay, which is 6.6. And if I put that on the calculator, that gives me 2.7 meters per second to 1 dp. Okay, that's the speed which is represented by the gradient at that time. Okay, and all I need to do is just say 1 dp or 2 SF, 2 significant figures. it wouldn't be normal to try and be any more accurate than that, because there's going to be quite a range of possible answers to this question anyway, depending on people's own graphs. Okay, but that's the method that you need to use to answer that question. Okay, in this question 20, we have a quadratic sequence, and we're going to find the expression for the nth term. So I'm going to set up a little table. This row is n, which is the position in the sequence. So that's simply 1, 2, 3, 4, 5. Okay. Then underneath that, the sequence itself, which is -1. Okay. 2, 9, 20, and 35. The first difference, 3, 7, 11, and 15. And the second difference is 4, 4, 4. If it wasn't the same, the second difference, then you've done something wrong, or it wasn't a quadratic sequence in the first place. I now take half the second difference, 2, and multiply it by n squared. 1 squared is 1 times 2 is 2. 2 squared 4 times 2 is 8. 3 squared 9 times 2 18. 4 squared 16 32. And this one is 50. Okay. And now I'm going to subtract s, the original sequence, and from that I'm going to subtract 2n squared. So this row take away this row. Okay, I'll just connect them together like that so you can see what I'm doing. I'm subtracting those two rows from each other. -1 take away 2 is -3. 2 take away 8 is -6. Then it goes -9, -12, and -15. Okay, that should be a linear sequence, which it is, meaning that we're probably correct. Okay. And what I'm going to do now is work out what that sequence is. Well, that's a linear sequence, and it's the sequence that goes down in threes. So it's -3n, and the 0th term would actually be 0 itself. So it's -3n plus 0. Okay. Now you combine that with this to give you the nth term rule for that sequence. So the answer to the question is simply, I'll put it over here, 2n squared minus 3n, and that's it. Okay. Next question. There's a biased coin, all right? So it's not a fair coin. And it's thrown 4 times, and the probability of getting 4 tails is 81 over 256. So I'm just going to say, let t equal the probability of getting a tail. Okay, so therefore t to the power 4 equals, so t to the power 4 equals 81 over 256. Because if I was working out the probability of getting 4 tails, it would be t times t times t times t. And if that's true, then t is the 4th root of that, which is the same as saying 81 over 256 to the power of a quarter. Okay, or you can use the 4th root button on your calculator. Okay, and what number times itself 4 times over gives you 81 is 3, and the 4th root of 256 is actually 4, because 4 to the power 4 is 256. So it's actually quite easy. So the probability of getting a tail is 3/4. So therefore the probability of getting a head must be 1/4 on this particular coin. okay, because it's 1 minus 3/4. So if the probability of getting 1 head is 1/4, the probability of getting 4 heads is 1/4. So the probability of 4 heads is equal to 1/4 to the power of 4, 1/4 times 1/4 times 1/4 times 1/4, which is just 1 over 256. Next. Okay, welcome to question 22. Now this one is an algebraic fraction, and what we're going to do here is recognize that this is a division here. So when you divide by a fraction, you turn that fraction upside down and multiply instead. So I've already written that out here to start with. Now I'm going to fully factorize it. So looking at the left, I've got a factor of 7 times x minus 2. Okay, and then on this part here, I've got a common factor of x, and in a bracket, x squared minus 36. I'll come back to that in a moment. And underneath all of that, we have a quadratic that factorizes. So this quadratic here has factors of minus 12 that add up to 4, and they are plus 6 and minus 2. So I'm going to write that as x minus 2x plus 6, okay? And over here, I still have the x minus 6 as well, okay? That's the first step. Now the next thing I'm going to do is recognize that over here I have the difference of 2 squares. Okay, so what I'm going to do to save a bit of time is just make a copy of that I've just written down, and then I'm going to just edit it slightly when I move it over here. So I'm going to leave most of it as it is, but that last fraction there that was x squared minus 36, that last part, I'm just going to take that out and write it instead as x plus 6 and x minus 6. Okay, so that bit becomes x plus 6 and x minus 6. Okay, and you can probably see what's going to happen next, because there's lots of opportunities here to cancel this all down. So let's start doing that now. So I'll just use a different color for this part. So I'm just going to strike through where a term on the top and the bottom matches. So we can take out an x minus 2 from the top and the bottom. We can take out an x plus 6 from the top and the bottom. And we can take out an x minus 6 from the top and the bottom. So in fact, we are left simply with 7 times x. And that's it. And that answers the question, because it says it simplifies to ax, where a is an integer. Well, there it is. It's 7. Okay, so that sort of thing often leads to a huge amount of cancelling out, which is exactly what's just happened. Next. Okay, a difficult question here. A lot of care is needed. Now, we have a cone that's been made up by taking this shape here, which is like a piece of card that's had the points A and B joined together to form this cone over here, okay? And we've got to work out the angle around this piece of card here, okay? In other words, the angle of card that's been cut out to make this cone. All right, so that's the thing we want, and we're going to call that angle theta, okay, which is what we're going to find out. Now we know something about this cone. We know it's got a height of 4. It tells us that in the question. It's got a volume of 60. We'll call its radius r, and this length here I'm going to call L, which is the slant height of the cone. Now, if that cone has been made from this shape here, it also means that L is the radius of this circle here. Okay, so using this formula for volume, I can write that 1/3 of pi times r squared times the height, which is 4, gives me the volume, which is 60. Now, if I divide both sides by 4, I will get 15, times by 3, I'll get 45, and divide by pi, I will be left with r squared, okay, r squared is equal to 45 over pi. Okay, so what I'm doing here is I'm going to have an expression for r in terms of pi, which implies that r is equal to the square root of 45, okay, over pi. Now, we don't need to know what the value of that is. We just need to leave it for the moment as the square root of 45 over pi. Okay. Right. So we're now going to work out the slant height L, okay, which is also the radius of this circle. So using Pythagoras' theorem, okay, I've drawn in a right angled triangle there. I know that L squared equals r squared plus 4 squared, or 4 squared plus r squared. Now, r squared is the square of this thing I've just square rooted. In other words, r squared is 45 over pi. Okay, so I'm now writing an expression for L. Okay, so if I just put that, well, that can be written as 16 plus 45 over pi. Okay, and I don't need to know what the value of this is. Okay, but what I need to know is that L itself is therefore the square root of 16 plus 45 over pi. Okay, so, and I need to put a square root sign around all of that. So I'll just do that across the top and finish off the square root sign. Okay, so quite a complicated looking expression for L and for R. Now, the next thing I could do is I know that the area of a sector of a circle is the angle, which is theta, divided by 360, okay, times the area of a circle, which is pi r squared. So theta over 360, okay, times pi, okay, times the radius squared. But the radius, we know, is L. So it's L squared, okay? And we know that L squared, pi r L squared, we know that that is the same as the surface area of the cone. So the area of this piece here that's been cut out from the circle is the same as the curved surface area of the cone, because that's what we made it from. And that is therefore pi times r, the radius, okay, times the slant height of the cone. So pi r L, okay, pi r L. Now, we can cancel out a pi from each side and one of the L's. okay, because this L can go and this pi can go, and then we're just left with an L here, okay, theta L over 360, okay, so I'm just going to write that down here, theta times L over 360 equals R, okay. And therefore, theta, which is what we need to find out, I need to multiply both sides by 360 and divide by L, equals 360 times R over L. Now, we've already worked out an expression for R and an expression for L. Okay, so what I'm going to do now is replace the R and the L with these expressions we've worked out earlier. So to find theta, then we have theta equals 360 times R, which I'm just going to take that out from here, okay, and bring that down here. So 360 times R, okay, and all of that is going to be divided by our expression for L, which is all of this. So it's a very complicated looking situation we've got here. So let's take a copy of that and put that under there. Well, of course, it is complicated, except that you've got a calculator. And you can put that onto the calculator exactly like that. And if you do, you will get 247.4 and more decimals, okay, and to 3 decimal places, or rather 3 significant figures, that's 247 degrees to 3 SF. Okay, now that is a very difficult problem, and it would be very easy to go wrong, and you have to have a clear plan and strategy for solving it. Okay, and very careful use of the calculator to get this. Okay, now we go on to the final question on this paper, and this is a vector question. Now I'm going to add some information onto this diagram. We're told that OX is A, so this is vector A, and the OY is vector B. But we also know something about the ratios. P is on OX in the ratio 1 to 3. So basically, if we took this line and divided it into 4 equal parts, O to P is one of them, and P to X is 3 of them. So if this whole thing is A, this part here is a quarter of A, and the other part is the vector 3/4 of A. Okay, and when you write a vector by hand, you should put the wavy line underneath it and the arrow showing its direction. Okay. When they print vectors, they print them in bold print like that. Now we also know that OR to RY is in the ratio 1 to 4, and it's the vector B that's along this direction. So this vector here is 1/5 of B, okay, and the vector up here is therefore 4/5 of B. Okay, 4/5 of the vector B, okay, with its little line and its arrow on the line there. Okay, so that's important information because we're going to have to express all the other vectors in terms of A and B. Now, we've got to work out in its simplest form the ratio ZP to ZR, okay? Now, in order to do that, I want to find a vector expression for ZR and a vector expression for ZP. So I'm going to start with ZR, okay? So Z to R, okay? Now I can achieve that by going from Z to O plus O to R. Okay, that's the same as ZO plus OR. Okay, and I can go a bit better than that because I can also break ZO up into ZY plus YO, because you see ZY I know is the vector A because it's parallel to the this vector here, which is also A. All right, so in fact it's better to write that as ZY, okay, plus YO plus OR. Okay, so 3 vectors added together to give me the vector Z to R, and that's easy enough to do because ZY is A, and Y to O is the reverse of O to Y. So O to Y is B, so Y to O is minus B, and O to R, as you can see, is 1/5 of B. Okay, so it's plus 1/5 of the vector B. Now, if you simplify that, you're left with A minus 4/5 of B. A minus 4/5 of B. Okay, so that's our vector ZR. Now, I'm going to find an expression for ZP, which is the whole line from there to there. Okay, so ZP, I can express that as ZO, which I've already done earlier, ZO, okay, which is these two here. Okay, so I can write it as ZY plus YO. Okay, so I'm doing this part here, ZY plus YO. Okay, and then I need to go from O to P, so that's OP. Okay, now using the lowercase letter notation, that gives me A minus B, okay, as before, plus OP, which is 1/4 A. Okay, right, now I'm going to also recognize that, let me just simplify that, that gives me 5/4 of A, because it's A plus 1/4 of A, so it's 5/4 of A, okay, plus, minus B. Okay, now I'm just going to notice that if I take out that factor of 5/4 from the front to the front of a bracket, it's 5/4 of A minus 4/5 of B. Okay, now the reason I've done that is so that you can see, hopefully, that the vector I've just put in brackets there is the same as ZR. So what I can actually say now is that the vector ZR, okay, is exactly the same as 5/4 of the vector ZP, I should have said, that should be ZP there. So ZP, okay, is 5/4 of ZR, okay, because that vector there is ZR. If I times it by 5/4, I get ZP. All right, so that means that the ratio ZP to ZR, ZP to ZR. So the lengths of those two lines, you don't actually need the vector lines on there now, because these are now referring to the lengths of ZP and ZR, is in the ratio 5 to 4. Okay, that's quite a tricky vector question to do, okay, and it takes a little bit of time and patience to work through, but that's the answer to the question, and that's the end of paper 3.